All right, let's go into inference with two independent sample means. Okay, I stressed that they are two separate independent samples, meaning the subjects in one are not in the other sample. Okay, because tomorrow we're not going to have that case. We're going to have actually data that is matched and paired, and they're not two separate independent groups of subjects. Okay, so let's see what's different about this than something we've already done. Here we go. In our assumptions, again, make sure you say random, that we are stated or assumed that both of these samples are randomly selected or from their populations or randomly assigned to their treatment groups. Independent, each sample, so both samples, N is less than 10% of the population, okay? And then we're saying the two groups have to be independent of each other. Okay, that's the big deal today as opposed to tomorrow. Subjects are not in each other's groups. All right, and then you have this large enough, which we talked about yesterday. Remember, we're checking it for both samples. So if they're both greater than or equal to 30, then we're good to go. If they're smaller, then you're checking to see if that population had followed the normal model. And then as a last resort, you might have to do the dot plot or the histogram you could have to do it for both sets of data. So that would not be ideal. Having to do two histograms and say they both are somewhat symmetric, unimodal, and no outliers, so the approximately normal model applies. Okay. But otherwise, we're going to be doing this just like we had done two proportions. Now, in a minute, we're going to get to doing this on our calculator, because remember, I let you do two sample tests with your calculator. We do ones by hand, so we continue to understand the fundamentals of what's happening. But I let you do two in the calculator since that's kind of some intricacies that we're more likely to maybe mess up in the calculation. So we'll go ahead and use our calculator for that. So let's do this example, and I'm going to explain. When we get to our calculator, I'll come back and revisit this. There's this thing about a pooled sample, and so we'll talk about that when we get to it in our calculator. All right, so let's talk about our first problem that we're going to do. We have a dietitian who developed a diet that's low in fats, carbohydrates, and cholesterol. So, although the diet was initially intended to be used by people with heart disease, the dietitian wishes to examine the effect this diet has on the weights of obese people, so not just heart disease. So, two random samples of 100 obese people are selected, and then one group is assigned to the low-fat diet, and the other 100 or the other group is assigned. It doesn't say assigned, but it I think implies this here, to the diet that contains approximately the same quantity of food, but they're not as low in fats, calories, or carbohydrates and cholesterol. So each person and the amount of weight lost or gained in a 3-week period is recorded, and here's the results. So we had here's the average, and here's the standard deviation, and here are two different treatment groups: the low-fat diet and the other. So well, I went ahead and I did my parameters here. So the mean of the L is the average weight loss of all such people on the low-fat diet for the 3 weeks. And mu of N, because I didn't want to put mu with the little o. That's kind of dangerous because is that like the null hypothesis or what? But so I put N for the non-low fat diet group. So mu of N is the average weight loss of all such people on the non-fat low fat diet. Okay. And then here are the assumptions. So I actually we're going to do an interval and a test. So on this page, I just did the parameters, and then here's our assumptions. So let's look at those for both groups. Here we go. Random. It was stated that these 100 obese people were randomly assigned to the low-fat diet and stated that the 100 obese people were randomly assigned to the non-low-fat diet. Independent, N is less than 10%, so this is our it's small enough. 100 is less than 10% of all obese people that we can place on the low-fat diet, and 100 is less than 10% of all obese people we can put on the non-low-fat diet. And then looky here, here's my important thing for 2. Independent means is that the obese people in these 2 different samples are independent of each other. So nobody's in both groups. All right, so for our large enough, it is. Yay. So we have 100 is greater than or equal to 30 in the low-fat diet sample is large enough, and 100 is greater than or equal to 30 because the non-low-fat diet sample is large enough. So the approximately normal model applies. Okay, we're good to go. Now, let's move on. So here in part 1, we are asked to make and interpret a 95% confidence interval for the difference between the mean weight losses of the 2 different diets. So that's an interval, so that's our panic. So I went ahead and wrote, look, the parameter and the assumptions are stated on the previous page. So the name of this is a 2-sample T interval for means. So let's talk about putting this into the calculator. So here we go. So get your calculator. So I've got this pulled up here. And so I can go in here to stat over to tests. So here I go, stat over to tests. So let's take a look at this. All right. So remember that the one proportion Z numbers 5 and 6 have the word proportion in them. So those are proportions. Unless it has the word proportion, it's about means. Okay? So that's a whole lot of mean stuff going on here. Let's take a look. What is this Z test and then T test? Those are for one sample. And then look at number 3 and 4. 2-sample Z test and 2-sample T test. What's that? Well, let's investigate. What's the difference between these? Obviously, one's for Z's and one's for T's. Well, as you know, Z's are for the normal model. Well, what did I tell you when we first learned about this T distribution? What made us have to use a T distribution instead of the normal model? The sample standard deviation. So I want to look at the difference between number 3 and number 4. Let's go do that. Here we go. Number 3 has this information here. And let's come on over here because we're going to be using that stats. I'll talk about these 2 tabs, data versus stats, in a minute. But look here, stats. Look at this symbol here, sigma for 1 and sigma for 2. That is the population standard deviation. Population standard deviation. So in order to do Z-test for means, you have to have the population standard deviation, and we don't. We rarely ever do, which hence is why we're doing t-tests. So let's go on to that menu. Stat, over to tests, go down to number 4. Okay, here we go. X bar, that's our sample mean. S of X, sample standard deviation. T, not Z. If we're using that sample standard deviation, then we're doing the T. So this is what we want. 2-sample t-test because we have sample standard deviation. So let's go put our information in. So I see that in my notes here, or what I had down here at the bottom, I am going to use the low-fat diet for the first one. So in my calculator, I'm kind of making a mental note. For the calculator, I'm going to consider that my group 1, and then this is my group 2, okay? So the non-fat diet's the group 2. Okay, so here we go. So for the low fat, the mean is 9.3 with a sample standard deviation of 4.73. So here we go. Here's my group 1, 9.3 with a sample standard deviation of 4.73. Is that what it said? That's not good. 9.3, enter. 4.73, enter. What's the sample size? Sample 1 was 100 people. Okay. Group 2. Group 2 is my other diet. That's 7.4 and 4.04. So here we go. 7.4 was the average of the sample. 4.04 is the standard deviation of the sample. And it also had 100 people in the sample. Okay. Oh, pooh. It's a test. This is a test. I did that whenever I was making the answer key also. We're not doing a test. What are we doing? We're doing an interval. So we'll come back to that in a minute. All right, let's go on over here. Look, I want to do a test. I want to do an interval. So here we go. Let's try that again. Stat, over to test. Go on down. Tests are first. Go down to the intervals. Keep going, keep going, keep going. Here we go. 0 says 2 sample T interval. There's our interval. Okay, that's the one we want. So let's do that. Well, yay, the information I just put in carries over. X1 is 9 point, X bar 1 sample mean, 9.3, sample standard deviation, 4.7. All that stuff's there. Yay. And then it said confidence level is 0.95. So we're good. Now, here's that weird thing that I was referencing. Pulled. No or yes. What in the world is that? Well, let's go talk about it. Okay, I put it here on the first page. Let's talk about pooling. All right, here we go. I wrote pool closed. No, we are not going to pool. Okay, you and I never go into the pool together. You do not want to see me in my swimsuit. Okay, not going to happen. Never, ever are we pooling. But let's talk about what that is. So technically, and the advantages to pooling are quite small. It reduces the variability and allows you to be a bit more precise in your estimations. Okay, but you are only allowed to pool if the variances were the same, if they had equal variances. So that would mean, remember, variance is the standard deviation squared. So those standard deviations would have to be identical to have same variances. Well, we don't have that. I mean, can you think of a situation? I can't. It's rarely ever going to happen that you're going to get random data and they're going to end up with the same standard deviation. I mean, they're pretty much not going to come up with the same mean, much less the same exact standard deviation, okay? So it's just not really going to happen. So it's not reasonable, okay? So we are not going to pool. So don't ever pool. So let's go look at our calculator. So see that right there? Pooled, leave that at a big old no. No, 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 no. Now, let's talk about this tab right here that says data. Let me reference that when we come back, when we go to the end. So let's go ahead, come on through here and calculate. We'll calculate. So, ta-da, here we go. This is our confidence interval, and here is the degrees of freedom. Whoa, degrees of freedom, is that not 99 plus 99 or whatever? It's not. I've tried to figure out what it is. Like, is it even like 99 squared plus 99 squared and then the square root of that. No, it's not even that. So there's a much more complex formula, which we do not need to know. Okay, it's not a first course statistical concept. So we will always just write down what the calculator gives us. That's a common expectation from the College Board. Okay, so that's what we do. We come on over here and I have shown you. Here is what I typed into my calculator. Here is what my calculator gave me. And so, of course, these two things you don't write down. This, what I have in red here, that's what you would write down. So look, don't you forget to tell me the way that you subtracted. This was missing on many quizzes that I graded in section 7B, quiz number 2. So tell me the way I subtracted. I did the low-fat one first minus the non-low-fat one, and it gave me this number. Now, I kind of did a little stutter step today whenever I came up with this interval because I was like, whoa, wait, hold on a second. 3.13, because my brain was still on percents. I was like, you can't have 313%, but this isn't percents. What is this? What are these numbers? They're the difference between the average weight losses. These things, what units are these? They're not percentages. These units are pounds. So that means that I am 95, right here, let's look at that. I'm 95% confident that the true difference between the average weight loss of the two diets is between this many pounds and this many pounds. And don't forget to tell me more weight loss for the low-fat diet group. You could also say this a different way. You could say I'm 95% confident that the average weight loss on the low-fat diet is between 0.67 and 3.13 pounds more weight loss than the average weight loss on the non-fat diet. Okay? Then remember, since this is about a difference, then we have got this situation where we have the 0 in there. So do you see that the difference is completely above 0? So this tells me that there is a significant difference in the weight loss. Okay? So because 0, so that's what I have here, because 0 is not in the interval, this appears to provide evidence that there really is a significant difference in the average weight loss of the two diets. Okay, so there's your conclusions on that. Now, don't forget to state that degrees of freedom, which you must get from your calculator for 2 sample tests because it's such a funky formula. That's an expectation. All right, next, let's do test to see if there is a difference. So let's get statistical evidence of a difference. So that's a phantoms. And so you can see I wrote here P, the parameters are stated on the previous page. So our null hypothesis is that those are equal to each other. And my alternative is that they are different because this didn't ask, is there more weight loss on the low-fat diet? This question said, is there a difference? That is a not equal to. Okay? All right. And then the assumptions are the same as the previous page. Okay. This is a 2 sample t-test for means. So I came on over here to my calculator and I went stat over to tests and I went down to number 4 and voila, the data's still there. But hey, let's go down to this, this alternative hypothesis Right here, look, I need to do the not equal to. Are we going to pool? Heck no. Okay, so let's move it on and let's calculate. I think I just hit clear instead of calculate. So let's do it. Here we go. Calculate, and let's see what we came up with. There is our t-score, 3.05, and they got the p-value for one side, and they doubled it. So this p-value here is both tails. The calculator gives you both tails. So here's what you write down for the t part of your Phantoms model. The t-score, the p-value, and again, if you did a not equal to, that is for both tails, and then the degrees of freedom listed right there. So O, obtain this p-value and compare to alpha. That's definitely less than our alpha, so we reject HO. So since the p-value is less than alpha, there is evidence to suggest that there is a statistical difference between not just the weight loss, the average weight loss. That has to be in there because you are not stating statistical evidence about a person. You're stating statistical evidence about the average of people's weight loss. Okay? The average of the whole population of all weight losses on that diet. Okay. So just this one little thing here, let's take a look at what can go wrong and what things do we need to watch out for. So this thing here, watch out for paired data. That's what we'll talk about tomorrow, where they are not independent of each other. They're not independent groups, but they're somehow connected. And then, of course, see here that they're independent. So that's important. Now, but here, if you just had individual data given to you, so if instead of, let's get off of that. Can you go away? I don't know how to get that thing away. Go away. If instead of being given these summary statistics here, you were given individual pieces of data like the first problem on your homework, your assignment. So this problem had two small samples, a sample size of 8 and a sample size of 10, and you had all the individual data. Now, this was an actual AP problem, and they did happen to give you the summary statistics as well. But I'm going to ask you to please not use this summary statistics on this problem so that you can have the experience of what to do here. And so I'm going to show you how to do that. And so what I have is, if I go to Stat Edit, here we go. List 1 is the 8 links of the buy right fish. L2 is the 10 links of the fish at Fish Friends. And you're asked if they are different from each other. So we have information in its raw data format instead of its summary statistics. So let's go calculate. Stat over to tests. Let's say we're going to do a test of a 2 sample t-test, number 4. And look at the tab for the 2 ways you can input information. You can input information in the data section as raw data or as summary statistics. So we're going to do it as raw data. So I hit the raw data tab, and there we go. So list 1, my first group, my buy right pets is in list 1, and my Fish Friends information is in list 2. I don't have any special frequencies happening, so those are just one or that's nothing there. Now you'll want to pay attention. I think this problem is investigating the problem with the fish friends and by right is investigating if by right is, I'm sorry, it asks if fish friends is greater than by right. So since I put by right in first, I want to see if by right is less than fish friends. We are not pulling, and then you can come on down here and calculate, and voila, it'll give you your t-score and your p-value and your degrees of freedom and so on and so forth. Now, look what happened. The sample mean was 3.4 and the sample standard deviation was 0.434 for group 1. Look, if you look under this stuff I scratched out, yep, by right pets was 340 and 0.434. And then fish friends was this 3.46 and 0.550. And yep, that's the summary statistics for fish friends. Okay, so in your information, you have two options of how to input your information. Either the summary statistics, which is this tab here to the right, so your summary statistics, or individual data right here, okay, and which you have placed it in the lists. All right, I think that's the end. Now let me just kind of show you what other information that I have provided for you. Let's see, yeah. So the other information I provided for you, so here is, the summary, a resource that I had given my AP students, so I went ahead and included it here. This is just written down for you how to use the calculate information, stats versus the data input. I fixed it on the document data. Okay, and so on. So this is, and then here is some conclusions. Talking about, there's your conclusions for an interval. Okay, so there's two different conclusions for intervals. One contains 0 and one does not. And then here is should be a exam. Okay, so then here's two independent means t-test. And so then I give you information on how to do that. And here's your conclusions and so on and so forth. Okay, and so there you go. That is your two independent means and some different things on how to do that and to use your calculator. All right. I hope that helps you. And good luck on your assignment where you will do 2 AP free response questions. Okay, do 2 AP free response questions. And then multiple choice questions that involve 2 different samples. All right, so they're all coinciding. And then, of course, your AP tester trio if you're going to be AP testing. All right, that's it. Good luck to you.